Hi, this is F3 Lines again. This is the overview part 2. On this video we'll be talking about the point slope and slope intercept, the equations of vertical and horizontal lines, which we just kind of discussed in the overview part 1 when we talked about their slopes. We're also going to talk about the general form of lines. So basically different ways the forms of lines can look like. And then we're going to finish it off with the parallel versus perpendicular line comparison. And so we're going to begin with point slope. Now, point slope is a way to write in a line, and I'm not really a big fan of it. I'm more of a fan of the slope intercept form because everything that can be done in point slope can be done in slope intercept form. And so I'm into the opinion of why memorize two formulas when one will do. Why? It's because some books will use point slope, and they will also use slope intercept form. And well, let me begin with what the point slope is. So point slope of an equation of a line looks like y minus y1 equals m times x minus x1. That's the equation of a point slope. Now, that should look somewhat familiar to you, even if you haven't taken this class before. If you looked at my overview part 1, that equation should look very familiar to you. It just looks differently than what I wrote in the other one. But what this formula does, it allows you to come up with an equation of a line as long as you know its slope and you know a point on that line. That's all you need. So you need one point and the slope of the line, and you can find the equation of the line, no problem. So yeah, where have I seen this before? Well, if you recall the slope formula, m equals y2 minus y1 over x2 minus x1. And since I told you just now that you'll know a point, so it doesn't matter, you know one of the points. So I'm going to say I know the second point, the x2, y2. So this will go away. The subscripts 2 will go away. So y minus y1 over x minus x1. Okay? So that equals m. So what I'm going to do is I'm going to take this x minus x1 and multiply it to the other side. And you'll go like, oh, there it is. So m times x minus x1 equals y minus y1. And if you use symmetry and put y minus y1 on the other side, the m times x minus x1 on the right side, you get the point slope formula. So you have probably seen these formulas before, and you've seen this before, and you've seen this before, but you may or not know there was any kind of connection between those two formulas. The connection is direct. It's the same formula. It's just written in a different way. Now, the other formula that we use is called the slope-intercept formula. Now, the point slope is used when you know the slope, and any other point will do. Any other point. Doesn't matter what the point is. Now, the slope-intercept formula is close, but you still have to have the slope. That's why it's called slope-intercept. The intercept is the y-intercept. So you'll use this one when you know the y-intercept. So it's y equals m times x plus b. That's the equation of that one. So you're like, well, how do you said a while ago that you always use slope-intercept and you don't use point slope. Well, the b can be found. So when you know a point and you know a slope, like this one does, instead of putting the x coordinate here and the y coordinate here, and then put the m in and doing the math, what you do is you put your x, y coordinate that you know, the point, not necessarily the y-intercept, put the x, y coordinate into this x and this y, you'll have the slope and solve for b. And then you already have the m, and now you'll have the b. And so, and again, we'll be doing some problems like this in some following videos, and I'll show you what that connection is. But you're going to note that point slope is not really your friend. You know, a lot of people have memorized it, and that's no big deal. But as I've said previously in videos, more formulas you have to know, the more you're likely to make a mistake. I mean, you could put a plus there, and that's a mistake. Put the x's on this side and the y's on this side by mistake. So there's a lot of times you have to memorize a formula. Well, you've got to know the formula verbatim. You can't miss a sign. You can't miss a letter. Misplacing a letter from one place to another place. Any mistake on any part of that formula, major or minor, it doesn't matter. You're going to mess up the answer. So that's why I like to minimize the number of formulas that I've had to memorize. So when I have two here, and I know one will really do for anything I have to use it for, then I'll just stick with that one. And you may disagree with what I'm saying there, and you may say, no, I know the point slope and I'm comfortable with it and I'm going to use it. I don't have a problem with that. Just be prepared to memorize more formulas. That's all. So, it's just I just go the easy way out when I can. So that's the slope-intercept formula and the point-slope formula. And you use both of them basically when you have the slope known and the point known. So, and this one is basically any point. This one's the y-intercept. But you can use this one for any point too, like I just said. Now, equations of vertical and horizontal lines. So vertical versus horizontal lines. Now, the biggest thing about this one is students getting mixed up with the equations of which one goes with which one. And I have ways to remember it. It's just you got to remember the one you're doing. And I will show you the technique that I've used. Let's say you have a point A, comma B, and I know this one's in the fourth quadrant, but that doesn't really matter where it's at. So let's say you have a vertical line going through AB. It has an equation. So right through here. So that's a vertical line through AB. And this one is a horizontal line through AB. So both of those lines have a particular equation because they go through the ordered pair AB. It's not one of the point slope because it doesn't. One of these lines don't even have a slope, and because it's a vertical line, it's undefined. So you couldn't even use that if you wanted to. But the one that is going through AB that's vertical, if you note, every point on that vertical line has the same. One of those coordinates is the same on every one of them. I mean, if you go through here, what is that point? Well, you go right A and then down to B. Here you go right A and you stay at 0. So this one has the point A0. So the x-intercept is A0. And this one right here is the y-intercept and it's 0, comma B. Now this is how I remember it. So I look at the x. I look at the intercept that it crosses at. So the vertical line that goes through AB has an x-intercept, and that x-intercept is A0 because it has to have. You go right on both of these points to get to these two locations. Sure, the other one you go down, but this one you stay put. But they have the same x-coordinate. So the x-coordinate is A. That's the equation. So it's x equals A. Now the horizontal line, okay, that goes through there has the same y-intercept. 0B and A, comma B. So the AB you go right and then down B, and then the y-intercept you go straight down to B. So it has the same y-coordinate. Same, the y-intercept and the y-coordinate of that point AB is the same. So its equation is y equals B. You'll be surprised how many people get those mixed up. I mean, I can talk to some Calc 1, Calc 2 students, and they would get those mixed up. It's because they don't see it that often, neither do you guys, and it's just hard to remember. And so I'm just giving you a little device of how to figure out which one goes. Look at the intercept. So if a vertical line The vertical line has an x-intercept. So it's x equals A. The horizontal line has a y-intercept. So it's y equals B. It's worked for me for years, and I never have that memorized. I just remember that part, and that's how I remember. Is it x equals A, y equals B? What is it? That's how I do it. So, all right. So that's horizontal and vertical lines. Yeah, and it's still the same old thing. Vertical lines is undefined slope, and the horizontal lines have slope that's 0. As a matter of fact, that horizontal line would go right into connection with this y equals mx plus b. Because look at that. If that's y equals mx plus b, what is the slope of a horizontal line? It's 0. Look at there. Y equals b. Look at that. Because the slope is 0. It doesn't work on the other one, but if you can get this one right, then but the other one would have to be right by default. So y equals b, another way to figure that out is on a horizontal line, on y equals mx plus b, the m is 0, plug 0 in, and you end up with 0x plus b, and so y equals b. So it's another way to remember that. So, all right, so now the general form is ax plus by equals c. Now, you're like, well, what's that mean? What is this general form of lines for? It's basically done so answers can look the same. It's conformity is mostly what it is. Sometimes when some people use the point slope formula and other people will use the slope intercept formula, if you leave it in that format, the answers are different. So when you go look in the back of the book and you're doing it this way, the author of the book might be doing it this way, or vice versa, and your answers don't match and you think you've done something wrong. So what you want to do is, well, I do it this way, and the author's not going to do it this way. The author's going to go and put their final answer in general form, and so should you. So if you go to point slope formula and use that technique, whereas your neighbor beside you uses the slope intercept formula, okay, so you're doing different techniques. Your answers can look the same if you put it in general form. So what that basically means is when you get y equals mx plus b, you would take the x's and y's and put them on the same side. Here on the point slope formula, you would distribute the m, put all the x's and y's on one side, and combine the numbers on the other side. And if you do that, no matter which way you go with it, and you put it in general form, they'll look exactly the same. But the A, the B, and the C are real numbers. So I like to say something else too. I like that if the A is positive. It's not a requirement. It doesn't say that in any book I've ever seen before, but I like having the A positive. If you have like 2x minus 3y equals 6, you can multiply through by negative and make that 2x at the very beginning negative 2x if you wanted to. But then it'll make it a plus 3y and a plus 6, or equal to plus 6 on the other side of the equation. The equations are identical. It's just leading off with that negative 2x to me doesn't look right. And most books that I've ever looked in the back of the answer, in the back of the book, if there is a possibility of that x being negative, they'll multiply through by negative and make that A on front positive. It's kind of an unwritten rule. So if you want to use that technique, that's fine. So, but it doesn't have to be. So A, B, and C are just real numbers. Any of them could be positive or any of them could be negative. So, all right. And then parallel versus perpendicular lines. This is when two lines are parallel. Now, there's two definitions of it. There's parallel lines in geometry and parallel lines in algebra. Okay, parallel lines in algebra are two lines on the same plane. Okay, that never intersect. That's what parallel lines in geometry is. Here, it's two lines that have the same slope. You know, so you don't mention slope in geometry, but you do mention slope in algebra. So you can talk about parallel lines in either course, but a geometry teacher is never going to mention the word slope to you. They're just going to say these are two lines on the same plane that never intersect. That is the visual part of it. But if two lines are on the same plane that have the same slope, okay, and have a different y-intercept, they're going to go run right wrong, and so it'll fit that definition perfectly. So two lines that have the same slope, two different lines that have the same slope. That's what parallel lines are. Perpendicular lines are two lines that, in geometry, are two lines that on the same plane that form right angles. In this class, in an algebra class, it's going to be two lines whose slopes are opposites and reciprocals. They have to be opposites and reciprocals. So parallel lines is if this one is 2, then this one has to be 2. They have to be the exact same number. So the slope of line 1 is 2, the slope of line 2 has to be 2. They both have to be the same number. Whereas on this one, if the slope is 1/2, and that means it's going up from left to right, then the other one is going to be going down from left to right. And its slope is going to be opposite of 1/2, which is negative. And then the reciprocal of 1/2 is 2. So it's going to be, slope of the other line is -2. So simply put, parallel lines, the first slope is equal to the second slope. If that happens, they're the same slope. So if you knew the slope of one line was 2/3, and you knew that a different line has a slope of 2/3 as well, then they're parallel. No questions asked. They're just going to run beside each other without intersecting. Now, perpendicular lines, this is going to happen. So if you multiply two lines that have perpendicular lines, then their slopes are -1. Because what is 1/2 times -2? It's -1. So when you multiply the two numbers, it gives you -1. Now, this perpendicular lines is kind of awkward when you're talking about horizontal and vertical lines, because on a horizontal and a vertical line, they're perpendicular as well. They're not parallel, but they are perpendicular. But this one doesn't really fit the category, because this one is slope is 0. Well, if you take the reciprocal of 0, you get undefined. So when you find the slope of a line that's horizontal and take the reciprocal of it, it's 1 divided by 0, and that's undefined. But what kind of a line has an undefined slope? A vertical line. Well, a parallel line and a vertical line are perpendicular. So these would be perpendicular by definition. So the only kind of exception, if you want to call it an exception, is that two lines are perpendicular. If one's a horizontal, the only line that's perpendicular to a horizontal line is a vertical line. So now, if they're diagonal, if one's got a positive and the other one's got a cut through here like this, that would be a right angle. But one's positive and the other one is negative. So that's why they have to be opposites of each other. The only exception is, like I said, when one's parallel, one's vertical. But one's parallel, it's 0. The one that's vertical is undefined. But the reason that the negative is because it's ones that are slanted. One's going like this, one's got a positive slope, and the other one's got to cut through there like this. And so if one's going up, one's going down on the other side. So one's got a positive slope. And that's why it's the opposites. And the reciprocals is because of the rise and run has to be changed over. So that's kind of the way they are in perpendicular. Parallel is easy, because parallel is whatever one is, the other one is. You're like, well, what happens if they're not equal? Then they're not parallel. What if they're not negative reciprocals of each other? Then they're not right angles. But then what is it? Well, there's just two lines that are crossing. So if you have two lines, they can cross. That means they're not parallel. But they may not be crossing at right angles, which means they're not perpendicular. So they're just two lines that kind of come like this, and one's kind of coming like this, and so they do cross, but they're not special to each other. So these are like special lines between two, making a comparison between two lines. Two lines that are parallel have the same slope, and two lines that have negative reciprocals are perpendicular. If they're not those, then there's no relationship between the two lines really, other than they're crossing someone at some point. So, okay, so this is the overview part 2. And we have actually 4 more videos for this section. And we're going to be talking about, in the online text, we're going to be doing a video for problems 11 through 30. We're also going to do another one from 31 to 70, and then another one from 71 to 90, and then some from 91 to 106. So this is going to be 4 more videos. Hopefully they'll be pretty short because there's not going to be too many problems to talk about. But there's 6 online videos from this section alone. So thank you for watching.